got employment already, or there's still some looking? Good, Fabian. Is it from a co-op or outside the co-op? Side. Okay, so it's not who you were working with before. Do you mind if I ask who you're with, or is that confidential? Okay, good, good. They do a lot of agricultural. Oh, I can't think of the guy's name who runs it. He's been there for years. Hutchins, right? Doug. There's a Doug Small who's their structure. Oh, Sam. Okay, there was a Hutchinson, I think, owned it, or I can't remember his name, but and then there was a Doug Small who I think was their structural engineer, if I'm not mistaken. Good. Yeah, Sam Hodgkinson. Okay, you got it. I just go by last names. What type of position, Fabian? Contract coordination or design or a little bit of everything? Yeah, we'll give it another minute or so. Industrial, good, okay. Is there a chance you may be doing outside field work after? Morning, Pavel.
Hey, John.
Yes, sir.
Morning.
Good morning.
I just had a quick question about our lab.
Okay, Kelly, go ahead.
We had our average was, I guess, rounded wrong. We had it marked wrong. We had 9,050, and you had marked it wrong and said 9,000. The average was 9,016. Would you not round up in that case, even though obviously you're not supposed to? But
No, because yeah, I can see where you're coming from. You would just take it down to the nearest 50 because either way, stability, and unless you're really close on the borderline, but then I would look at it without even rounding it. Like if you were borderline, really borderline, I would look at individuals to the nearest mutant. But typically you go to the nearest 50. So
yeah.
if it means coming down, it means coming down.
Oh, okay. I just assumed that in design you would just round up, being that we're over 9,000.
True, I can see your point. I can see your
Mhm.
point there. So what do I do? Deduct half a mark?
Yeah.
Okay, I'll give you the half, but in the big scheme of things, it's not gonna change your final mark any. Because your
Okay.
final mark is to the nearest mark and it's just A, B, C, or D, or
Yeah.
F for failure, or
Yeah.
F for failure.
Well, I hope not. But yeah, that
Just
would be
remember, guys,
appreciated. But
yeah,
for our new lab, the numbers you had given us were the 9050. So are we just to change that to 9,000 then, or keep the 9050?
no, I gave it to you as 90/50, keep it as 90/50.
Okay.
Because what I was trying to do, you're gonna see those of you that started plotting it, not plotting it, plotting it, the curves might be coming out pretty good. Typically, that doesn't happen in the real world, but I kind of made it, I don't know, maybe I'm too much of a softie. I kind of made it easy for you guys. Because a lot of the interpretation comes from understanding the relationships of how flow goes with stability, how stability goes with AC content, how density goes with AC content, how air voids, VMAs, that type of thing. So that's why I made that little comment there that sometimes you have to leave out the outliers when you're plotting because you
Mhm.
got to get that shape of the curve. The shape of the curves have been determined from years and years of analysis.
Okay.
And if you physically ever get involved in physically running a full scale mix design with 4 or 5 AC contents, 3 briquettes for each and so forth, you can understand or appreciate the variability that can occur. And it's just sometimes Sometimes it's not testing properly, but sometimes it's just the anomalies of the mix. It's just, it is what it is.
Okay.
Okay. Any other concerns about the lab?
Um, your PB, that was just our, what we used that you had given us, right? Our percent
Right, you've
of
got a
vitamin.
design, but you got to calculate the actually.
Oh, so that is the actual that we're looking for, not the
That would be the,
5% we were shooting for?
no, you wanted the actual, because remember, if you've weighed out your aggregate, let's say you got 1,205 grams of aggregate, and you're gonna add 60, let's say you have to add 65 grams of AC for 4%. That's just an example. And you added 68 grams, or you added 69 because you overshot it. Remember, you're pouring it
Yeah.
in with your out of your kettle, and all of a sudden you're not accurate enough, and you, instead of putting 66 grams of AC, you put 68 or 69 or 70 grams.
And
And the
that would
thing
put
is,
us over the 5%. So we'd have to use
yeah, so
that.
then maybe it turns out to 5.2 or 5.15. That's the
Yeah.
actual. You got to
Yeah.
remember now, everything's going to be based on 5.15, not 5. 5 is what you're shooting for. So you might be under, you might be over, but you try and get as close to 5 as you can. And
Mhm.
the more mixed designs you do, you get pretty accurate after.
Yeah.
Yeah. So that's why we have to use the actual, the PB.
Okay.
Okay.
Okay. Thanks.
Yeah, you're welcome. Yeah, it's unfortunate we couldn't actually physically work this year in Carsey and do the touchy feely and get our fingers dirty and get our fingers smashed on the hammer.
Yeah, I think it would be a lot more helpful to go through the actual process and it would give you a much better idea of everything, right?
Yeah, yeah. That Marshall hammer, one of the things you do manually, you saw Art working it. Um, there's really no, there is a type of a shield on the bottom on some of the newer hammers, but I've worked in industry and I myself have done it. I smashed my finger where I smashed open my finger and I drew blood. And I had a couple of technicians years ago, and two of them were on the hammer, one kind of helping the other guy steady, and the other guy throwing the weight up and down, up and down, up and down. And again, you're doing 75 blows, and you want to do it fairly fast because you don't want it to cool off. Okay, you do a good rhythm. Well, anyways, one of the young students, I guess he's around 37, 38, 39 blows, he's counting, and he gets his finger smashed under the hammer. Because when he lifts the drop weight, his little pinky, as it's coming down, got caught underneath, and it just squashed it between the hammer and the jar plate on the bottom. And it split his finger wide open, and blood just squirted all over the place and all over the floor. So he dropped the hammer and he dropped to his knees because it just, I'm telling you, it's painful. I shouldn't laugh about it, but the other guy, instead of helping him, he picks up the hammer and counts 39, 40, 41. Meanwhile, the other guy's laying on the floor, grimacing in pain, squirting blood all over it. So
Yeah,
that's
I
just
can't
called
mess up that
dedication, I
mix.
guess. Anyhow, and our student a couple of years ago, actually, Ray's partner, when they were doing their ARP, uh, we were in Carsey one evening and I was helping them, and Claire got her fingers smashed underneath the hammer too, so she went to the hospital, but it was okay. It just had to heal. But anyways, so there are parts of this test that you can call it get injured. You can burn yourself if you forget to put your gloves on. You grab a hot mold or you grab a hot plate of asphalt. So you got to be careful. Anyhow, okay, we can get started here. This is going to be the last one as far as a recording, and unless someone wants extra ones. But because next week you're writing your final exam or final test, whatever you want to call it. I shouldn't really call it a final exam because typically final exams is all inclusive from day one right to the end of the course, but it's typically a progressive type of a test because it only covers units 3, 4, and 5. Excuse me. But anyhow, so and then there's going to be the volumetric air void analysis calculations. Also, there's going to be I don't know 4 questions, 5 questions. So again, your final exam will have the formula sheet for those volumetrics, and I'll give you that schematic. It shows the relationship between the air, the AC, and the aggregates. Again, depending on how comfortable you are. I had a student a few years back that did all his calculations, not even using the formula. He strictly used the schematic, the relationship between, the effective specific gravities, effective volumes, the total AC content, the absorbed AC content, the effective AC, and so forth. So you can do it either way. Sometimes the picture helps you to visualize what's taking place. Okay. So what I want to cover today, excuse me, you know that I scheduled only an hour and a half, but I mean, go longer, I can go less if need be. I want to cover the placement, something that you may be involved with depending on where you're going to be employed. Sometimes you may be inspecting hot mix asphalt going down. So there's things to look for. There's things that the contractor has to be really aware of and really keep in mind if he's going to have a successful paving job. So I want to cover some of those. Excuse me. Sorry about that. Cover basically the placement, the field work. Because we condensed this course for this year, we're not covering the plant work, the plant fabrication. Typically, we cover the plant, how the asphalt is manufactured at the plant, and some of the key areas, the bins, the calibration of the cold bins, the calibration of the kiln, where they heat the aggregates to phenomenal heat and add the liquid AC, how they mix it, how they put it up in the silo, some environmental concerns on the bag house, which basically is a filtration system. So that we're not covering this year because we had to condense it. But typically in the previous years, we cover all that, and it's quite interesting to see how the asphalt gets manufactured at the plant. What I always try and do, and it's a little tough because when we cover the asphalt section of the course, they're typically not batching yet. Okay, the plants haven't opened up. It'd be ideal to go over and witness a tour at one of the asphalt plants. Anyhow, you'll also notice that I loaded up into Learn 3 videos, part 1, part 2, part 3 on the placement. Please, for some of you, I know don't view the videos, do so. Fair warning, there's going to be questions on the exam and the quiz pertaining to those videos because it supplements what we're going to be looking at today in the placement and the compaction from a field point of view. So there are going to be 2, 3 questions maybe pertaining to the video. What I will do and will allow is for those questions pertaining to the video, I will let you open up those videos during the exam. But only those videos. Everything else is going to be shut down. So I'm kind of making it easier for you, but if you don't look at the videos, you're not going to know where to look because there's 3 parts to it. And the questions don't always relate to only one part of the video. So if you know your videos, if you know what's covered, if you have an idea what's covered by reviewing them initially, you should have no problem. And you may just remember some of the things. You may not even have to access those videos. But those videos are put up by the Public Resources Group in the States, and they're fairly good. They show you the methods which are applicable here. Sometimes maybe the numbers that they talk about are imperial. However, the procedures, the methods of construction, the placement, the compaction, they're all applicable to the art, if you want to call it, of hot mix compaction, placement, and so forth. Any questions? Okay, we're going to get to the PDF that I had put up, and we'll take it from there. Oh, sorry, I got to record. Okay, well, anyways, we're getting into it now. Keep forgetting. Sorry, guys. Yeah. Okay. Okay, so we're up and running. So like I mentioned, it wasn't in the recording, but I will, in case some people aren't on this synchronous delivery, do review those videos. There's going to be questions on the exam pertaining to those three parts of the video that is uploaded in this section for hot mix placement, okay? Okay, I'm going to open it up and we'll go from there. Okay, everybody see that okay? Chat down here so I can keep. Okay, hot mix placement. Essentially, we're building pavements. And you've seen that around City of Winnipeg. Some of you may have been involved, obviously, with highways and may have seen larger scales. Typically here in Winnipeg, we do what's called the TBOs, thin lip bituminous overlays. And typically, we repair the concrete streets, joints typically. We do joint repairs, sometimes full-scale restoration. And then we place the thin lift bituminous overlay back over the concrete. Most streets in Winnipeg, probably 99.8% of them are concrete. They look asphaltic, but that's because we place an overlay of asphalt material over it. Okay. So, hot mix placement. What are we going to be looking at? Come on. Okay. What we want to cover is hauling the asphalt. In other words, we're going to haul it from the batch plant to the job site. We're going to place it, and then we have to compact it. We want to make sure that we compact it so we get a good, durable mix that'll last for years and years. Typically, it doesn't last as long as concrete, that's for sure. Okay, what do we haul with? Well, numerous trucks. And again, depending on the size of the job. Typically, the upper left-hand corner you can see is a small dual axle tandem dump truck. A lot of them use the smaller ones around the city, but if you're getting out onto the highway projects, you may be using the semi-trailer dumps. The upper right-hand corner here, you're gonna see what's called the belly dump or bottom discharge. And here you've seen a lot of these are used for placing granular base because they can just run it out. And a good operator can run it out to such a way that there's gonna be very little work done on the grader to get it leveled. For asphalt here, it's done a little differently. They make a windrow. And then, depending on the paver, the type of paver, there should be a pickup arm to pick up that windrow and push it through the paver. Typically, bottom discharge or belly dumps they're not ideal. They're not ideal. Again, you can get contamination if your pickup arm isn't working and you could be picking up the base along with the asphalt. Typically, if you have a prime coat on it, it'll somewhat seal out the granular, but if you're just working with a tack coat, it can. You get a breakdown and you got all this asphalt rolled out. Now it's cooling down. It's a problem. The dump trucks, okay, they're tarped over, and you're only going to dump as you're moving along, and we'll look into that. So, doesn't say you can't use the belly dumps, but it's not as ideal. There's too many things that can go wrong with it. And typically, you don't want to lay out that roll way too far. Maybe one truck at a time only have enough rolled out or dumped out, truck by truck. If you dump out too much, say 2, 3 trucks ahead of the paver breaks down, you've just ruined 3 loads of asphalt. And obviously the bottom right-hand corner, you can see the numerous wheels for heavy loads and heavy volume. So trucks, typically we use the tandem dumps or the semi dumps. Okay, come in various sizes. Obviously the metal beds always have to be cleaned. When he dumps, you want to make sure that all the asphalt slides out, because if it doesn't, it just sticks in the corners and load after load after load. If it doesn't come out, it gets hardened. And you want to use a release agent, obviously not diesel. because diesel fuel softens the mix. Because if you're using diesel fuel, that's what you use to make cutbacks. Okay, you're diluting the AC content. If you dilute it, it's going to become softer. Number of trucks. Okay, this is important. How much? Okay, the guy's going to be trying to pave a kilometer of roadway, maybe 2 kilometers. How fast can the plant put out the asphalt? He has to know that. Typically, when you start paving, and we'll look at that, your paver starts up in the morning at 7 a.m., let's say, it should never stop until they're stopping at the end of the job. Now, that doesn't usually happen, but it shouldn't. If it stops and then takes off, what happens? Anybody? Anybody have an idea? You got a paver, and we're going to look at the paver shortly here. He's paving along, and all of a sudden the trucks aren't there. He runs out of asphalt. A dip in the pavement. You're right, Fabian. You get a dip in the pavement. Every time you stop that paver and take off, you're going to get a dip. And many times you can be driving down the highway and look ahead of you. I usually watch the white line on my right hand side. Okay, that shows you where the shoulder is. And you can typically sometimes, if you're looking further ahead, you can actually see a little bit of a dip. And that could be from stop and go. Okay? Some of the bigger operators have a load transfer device. So in other words, it's a hopper that's in front of the paver. So the truck discharges his load into the hopper, and then the hopper discharges it into the paver. So such that if you can keep that hopper, load transfer device, full, if he's waiting for a truck to come on site, or maybe to get into position so he can pick him up, he's always got asphalt feeding his paver, so he's constantly moving. So in the real world, you got to match your job, your placement rate to the plant rate. So whatever the plant puts out, that's what you base your trucks on. That's what you base your placement and compaction on. So the production rate of the plant, you have to consider that. The length of the haul from the plant to the paving site. Okay, take that into consideration. Is it 5 kilometers, 2 kilometers, 25 kilometers? Many times there's small paving jobs that are being done outside of Winnipeg, and they're going to rely on the batch plants in Winnipeg to produce asphalt. So they may take 30 minutes to get out to the job site, 45 minutes. You have to take that into consideration because now you got to look at turnaround time.
Hey, John,
Go ahead.
how much can the paving truck do in say like an hour? Like how far?
How far can you travel?
No, like so the ones actually spreading the asphalt, like how much can they actually do with that machine?
Oh, it depends on the size of the machine. It depends on the size of the mat. I've seen Ray Van Lanker who had a 500 ton an hour plant, and he always ran her full bore to the point that a lot of the guys on site were sitting. The trucks were sitting and cooling off because you can only pave so fast. So it depends on the thickness, depends on the width of the paver. Um, but I've seen if the trucks are coming and going, I've seen them keep up to 500 ton an hour easy.
Oh wow.
So that's a lot. But I mean,
Yeah.
that's a big plant. A lot of plants are 250, but Nelson River has some pretty big operations there. But when you see 4 or 5 trucks sitting waiting to back up to the paver, then what's happening is the field crew is not coordinating with the plant. So either the plant has to slow down on the production so the paving crew can keep up, or vice versa sometimes. Um, if you get too many trucks and the plant can't produce, then you got the trucks waiting at the plant for loading up. And then a lot of them get peeved off because some of them get paid by the load. So you can see here now that depending on the size of the job, turnaround time, type of traffic here in Winnipeg, you got to take into consideration. If you're going to be paving from 7 a.m. till 7 at night, well, you're going to be going through rush hour and you're going to be going through rush hour again in the afternoon. So now, if a truck can do a turnaround in 1 hour, an hour and a half, it may take them 2.5 hours now. So uh, And how long is it gonna take to unload? Access. Is it tight? Is it easy to get in? Are they gonna fiddle around a lot? So the amount you can do in an hour, there's just too many circumstances that come into play. Like right here, you can see the four factors. How fast can the plant do it? So in other words, there's got to be constant communication between the plant and the paving crew. Sometimes they may say slow down a bit. At the plant, they've got a silo. So as they're producing asphalt, there's a big silo that's a storage silo. So the plant can produce asphalt and keep it in the silo for quite some time. And the silos are all insulated so they won't cool down. And then the trucks just come in and they load themselves, pull out. Meanwhile, the plant keeps feeding the silo. Again, if the silo is full because they're not taking it fast enough, then the plant now has to decrease its production rate or maybe even stop for a while until they make room in the silo. So you, Pavel, you've witnessed 5.6 kilometer distance. Are you talking the actual paving distance or the distance from the plant to the paving? Actual paving. Oh yeah. 2 kilometers is I said 2 kilometers. That's a small job. Sometimes they'll pave 10 kilometers in a day, depending again how many lifts. Typically, they'll put the first lift down, and many times they don't do the second lift till later, and they'll put traffic on the bottom lift. They'll do the other lane, and then they'll flip them, or they'll do the second lane bottom lift, then they'll do second lane top lift, then they switch back to top lift lane one. So again, whether it's one lift or two lifts. Okay, so this is key. Number of trucks required depends on these four factors. Okay, discharge with end dumps. Okay. He loads directly into the paver. Well, look at that. He backs up, and then the paver picks him up. Never have the truck back into the paver. Okay, because when he bumps, if the truck is backing up and he bumps that paver, you got a bump in the mat. It's no different than stopping. So actually, the truck stops short of the paver. The paver comes up, picks him up. He's got dollies on the front of the paver that picks up the hubs. Truck's in neutral, and then the paver pushes the truck. All the truck operator does after is he booms his load up and down to feed the hopper, and we'll look at that. So he loads directly into the paver. Operator directs the truck squarely against the paver. Truck stops a few inches, actually. That should be a couple of feet. A few inches is pretty close. But what we're trying to say here is the truck should not bump the paver. Then he slowly raises his truck bed and the asphalt starts to flow into the hopper. The hopper is obviously the storage device of the paver, and then it's going to go through the paver and is extruded out the back, and then the screed levels it. And we'll look at that here shortly. Okay, so this is how it's done with the discharge. Excuse me, the end dumps, if you want to call them dump trucks. Don't worry about that symbol for some reason. I should just actually try and get rid of it. We'll do it later, no problem. Okay, okay. So here's the self-propelled paver. You can see the truck. Okay. On a small job, and I've noticed that they did it here in St. Adolphe one time, they put a little bit of an overlay over our main street, and they did a terrible job, but they didn't use a paver. They probably just used either a grader or maybe just a screed box. But here, graders can be used, but it's seldom done because it's hard to get the proper slope and the proper screed, and then you got to have compaction. So many rims got damaged. That happens, yeah. But again, it's also the operator, Pavel, on the paver. He's got to know how to slowly pick them up. Also, I don't know. I mean, we look into the maintenance of it, and the video picks that up. When you watch the video, they talk about maintenance of the equipment and the cleaning of the equipment. If those dolly wheels on the paver aren't smooth and they've got buildup of AC, whatever, he's going to damage those rims. scratch them and so forth. And some of those drivers, they really take pride in their trucks, especially if they've got the nice chrome wheels. Anyhow, so grader is very seldom used. You don't have the control. Purpose of the paver is to place the HMA, width and thickness, proper, and you want to get a good tight mat. I've seen so many mats, poor, 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 poor. Uh, Bottom lift, I know they don't take. Well, you got a point there, Sean, and they shouldn't use good rims, but I've seen some of those guys, and that's usually Jade that hauls the hot, not hot, but he hauls the liquid AC to the plants. They usually have their trucks pretty dressed up. But yeah, if I was a driver, I'd use just my black rims, the dark, busted up, no good rims on the trailers, but anyhow. So you're gonna place the mat thickness. Now your notes says 3 times. It should actually be 3 to 4 times. So just make a note of that. Typically the mix is 3 to 4 times the thickness of the nominal aggregate. You can't have too thin of a lift because if you got large nominal size aggregate, you're gonna have more, the mat's gonna be as thick as the actual aggregate itself. So you wanna have, make sure you've got coating around the aggregate. So your lift is dictated by the nominal maximum size of the mix, okay? And this is nominal. Believe it or not, if you're gonna look at the maximum aggregate size, it's only about 1.5 to 2.5 times the thickness. But we strictly work on nominal aggregate size, not maximum aggregate size, nominal aggregate size. Okay, so here you can see it in action. Okay, hasn't changed much, okay, since the 1930s. Same principle. You get hot mix, dump it in the hopper, and you screed it, packed it, and you get a flat mat on the backside. Well, not a flat, you're gonna have, sometimes you're gonna have crossfall, you're gonna have drainage to one side, okay, if you're doing one lane and then on the other lane. This is why you don't have the truck back up into the paver. Bottom dump trucks can be used when a pickup device is used to feed the windrow left by the truck and the paver, okay, these belly dumps. It is essential that the windrow deposited by the truck be as uniform as possible, because as you're picking it up, you want to feed the paver uniformly. Windrow material can cool below spreading and compacting temperatures in cool weather. This can be a major problem if the paver has a malfunction. To prevent excessive cooling of the mix in cool weather, limit the length of the windrow to no more than one truck ahead of the pickup machine, okay? Important there. So essentially, and the pavers aren't very large. I mean, it's amazing the amount of material they can place. They'll extend their screed many times if they're going to be doing some pave the shoulder at the same time or turning radiuses. So they have a fair amount of okay, I'm getting messages popping up here. Okay, and don't worry, you don't have to know the mechanics of the paving operation and how it works. I'll just go over it real quickly, but it gives you an idea. You've got the hopper that feeds the asphalt through the machine, and there's your back screed. Okay, on the slip-form paver, for concrete, you've got your augers in the front that levels the concrete to a uniform height and thickness to feed the machine. You have the back screed, the same thing. It's fed through the hopper. The screed, believe it or not, gives you compaction too. It's very important. The screed should be in very good shape, shouldn't have any nicks, and that screed can be adjusted to give you crossfall. And it's set up. Those of you that may have done density testing, if you don't have, say, 85 to 89 or even 90% compaction just from the screed alone. So in other words, before the rollers come on, before the compaction, if you're standing on the back of that screed and you put your nuclear gauge down and do a density in the backscatter method, and you know what the Marshall density is going to be, let's say you're working it from the previous day, if the screed isn't giving you 88, 89, 90% compaction before the rollers, you're not going to get it. You can roll compact till the cows come home. You're not going to get it. That screed, believe it or not, gives you a lot of compaction. So always look at it. Look at the maintenance. Make sure there's no buildup of material underneath it. Make sure it's level. Make sure there's no nicks, gouges. It's key because that's going to affect also the texture or the appearance of your mat. And this is just a single toe. This is just the screed itself that you would pull off. And you can see you can get an angle of attack here. Screed unit towed by the tractor establishes the thickness of the and provides initial texture to the new surface. The screed also imparts some level of density. The principle of the free-floating paver screed was developed in the early 1930s. So when you're watching a paving crew go down, and you're watching the paver and he's using string lines, okay, just like a slip-form paver will follow a string line to give you your elevation, the machine can move up and down. The screed should stay level because it should be coming off string lines. That concept allows the paver screed, which is attached to the tractor unit at only one point on each side of the machine, to average out changes in grade that are experienced by the wheelbase of the tractor. So the tractor can go up and down, but you want that screed to follow a certain elevation, certain crossfall, certain mat thickness. So it's called a floating screed, and it's got a single point, toe point, okay? And this is just the forces on the screed. You can see the asphalt has come through the paver and it's deposited. And here it's giving you the elevation that you require. So you got various forces. You got the machine, you got the angle, and you've got the force of the unit pulling. I'm not going to go through this. This explains how the forces work. I would read it just for your own interest. I'm not going to quiz you on it. We're not, obviously, at this point in time, we're not paving contractors. However, many of you guys may be involved on a paving crew. So those 3 videos that I've uploaded are actually pretty good because they highlight a lot of the things that the inspector has to look for. So it's a good resource. Okay, forces on the screed, and this is going to give you the quality of the mix that you want. Okay, basic functions of the paving machine. Okay, the tractor unit receives the mix. Okay, trucks bring it onto the job site, they dump it into the hopper. It's fed through the machine, and the mix is distributed across the full width in front of the screed. And then you always hope that you have asphalt in the hopper. If there's no asphalt on site and you empty the hopper, you've stopped. And it could be a good catch up, and you'll see in the video, these guys are laying in the ditch, deciding to have a coffee and a sandwich because there's no asphalt on the job site. So the workers enjoy it, gives them a break. However, you're gonna get a dip in the mat. Paver starts, never shuts down, never stops till it stops for the end of the day. That's the ideal situation. I don't know if it's ever happened. That's what you strive for. That's why if we go back to that previous slide, you got to take those 4 factors into consideration. Sometimes you may have too many trucks. There's nothing wrong in having trucks waiting on the job site as long as it's not too long. Okay? If they sit too long, even if they're tarped with insulated tarps, you'll see a lot of the guys will pull up on the job site and they throw the tarps back because they want to be ready to back in. Something happens, now you got to go back out, close the tarps up. B, okay, you got to be able to schedule your job, and it's not easy because there's too many outside circumstances that sometimes come into play that you may not have any control of. Okay, so you've laid the mat down, okay? you've extruded it out the back, screed, compacted it. The guy on the back has been checking the depth from time to time, and you'll see in the video how they check for depth. You see how they adjust. They have screw feeds on the side, on the back there, where they adjust the screed up or down. Typically, you shouldn't have to adjust too often. Sometimes you're on a job site and you see the guy just back and forth, back and forth. He keeps playing around with those controls. You got to remember, it's not instantaneous. It's going to take a while before they finally get that elevation. So when you see, as they call it in the video, can't remember the term, Whirly John or John Whirly or something, he's always whirling those height adjustments. It takes a while before you finally zoom into the required elevation. It's not instantaneous. So now we're ready to compact, okay? And again, this is key. You're gonna have a great mix, excellent mix. But if you don't know how to place it and you don't know how to compact it, your job's gonna suffer. You're gonna have poor compaction, you're gonna have poor densities, have higher voids, you're gonna have a very permeable mix. Oxidation is gonna take place, freeze thaw, okay? So good compaction leads to good performance. That's key, as the guy states. What is it? It's a process. We compress. We compress the mix. We reduce the volume. Doesn't matter whether you're talking about granular A base, C base, granular materials. You're compacting. You're consolidating. You're compressing the mat, the layer, whatever you want to call it, and therefore you reduce the volume. Reduce the volume, reducing voids. And a lot of times, high voids is going to give you problems. Whether we're talking about uh, asphalt concrete or we're talking about base soil, whatever. So there's some key points here as to why we compact. We know many times why we're compacting base materials. Okay, we want to prevent further compaction. We know we're going to get further compaction with repetitive traffic. As time goes on, your pavements open up to traffic, your vehicular traffic, heavy trucks, cars, whatever. But you're going to get further compaction. Obviously, we're going to provide shear strength against rutting. We compress it, we can compact it, we're going to get good resistance to rutting. Decrease the voids, we're going to decrease the permeability. Less infiltration of water, less freezing if it's in the fall or early spring. Low temperature cracking. Okay, we got a tougher mat, more durable, there'll be more resistance. And we're obviously going to prevent excessive oxidation, which goes in with the higher voids. The more voids you have, you're going to lead to permeability problems. You're also going to lead to oxidation with time of the binder. So those are key reasons why we compact. We have a good definition here. Very simple definition, but nonetheless, okay. That's all we do. We compress it, we reduce the volume. We also know now the temperature is going to be key. We know the temperature was key in the Marshall stability and fabricating the Marshall briquettes. Remember, we had a mixing temperature, the AC and the aggregates. We also have a compaction temperature. If the temperature is too cool, we're not going to get compressibility. We're not going to get that compaction. It's starting to stiffen. The viscosity has changed. Okay, we're getting higher viscosity. If it's too hot, and not only from the Marshall point of view, but from the construction point of view, if it's too hot, the paver is pulling ahead, compactor rollers, the compactors, whatever you want to call them, cannot keep up because the mat is too soft, it's too tender. It won't support the rollers. So they're going to wait a while until it cools off. Meanwhile, pavers moving ahead at a fast rate because the plant is pushing out asphalt and pushing out trucks, and the trucks are lining up on grade. Yeah, there's your problems. So there's so many factors that come into play. So now temperature is critical. Too cold, can't compact it. You can't get the density. Too hot, won't support the rollers. And you're going to have a series of rollers. We're going to look into that. And in the video, you'll also notice the key points. So temperature, critical, 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 all comes into play. Now, maybe it's too hot, maybe the plant. This is where the communication from the field comes in. Superintendent on the job site should now notify the plant and saying, hey, we're mixing way too hot. Now, maybe it's just a matter of slowing the production a little bit, but something to keep in mind. They got to check the plant right away. Remember that asphalt that's fed up into the silos, those silos are insulated, and there's been projects where the plant had to shut down because the paver broke down. In other words, the field work shut down. They couldn't fix the paver. They had problems, so they shut it down for the day. You've got a silo full of asphalt at the plant. By next morning, you want to start up again. If you fix your problem, that asphalt in those silos sometimes is still hot enough to be used the next day. But if it's not, you've wasted. Can't reheat it. If you shouldn't, whether the contractor does or not. Okay, so here he's doing math temperatures. He's using the surface thermometers, and he's using the infrared gun. These guns give you a good indication. I don't think they're very accurate. Depends on the distance that you're shooting from your gun to the mat. Surface thermometers have that bi-metal coil in the back, and you can calibrate them, see if they work good. These are, they come down in price also, but again, the accuracy is only as good as the manufacturers. You buy one for 20 bucks, or you buy one for 220 bucks, totally different sensitivities. So temperature, critical. We're going to look briefly at some of the rollers. You've probably seen these. The vibratory rollers. They are also static. So in other words, you can just have the drums rotating. There's no amplitude, there's no vibration. You've known the D's, say on granular base many times when they're building granular base, they'll be vibing. In other words, they got the vibrators on, you can feel it, okay? He for asphalt, he's got a sequence here. He can go in with the vibes, back out, static, static, vibe out, vibe in, vibe out, back and forth. Again, you see these guys on the job site and everybody says, oh, what an easy job. Not right. Performance of your mat is based on how good of operator you have on these compactors, if they know their stuff or not. Because again, that's what might be good. Construction is going to kill that mat. It's either going to improve it or it's going to make it really bad if you got inexperienced operators. So yeah, it seems like a boring job, but that's one of the most important. It's like everybody says on a paving job, the flag person is the low man on a totem pole. The flag person on any paving job has the most important job. They may have the less pay, so that doesn't go hand in hand. But a flag person on any job is key. If they're sleeping on the job, you can have fatalities. They're looking at the safety of the public, the motoring public. So the same thing here on these pavers. You're driving these compactors back and forth, and everybody says, "Oh, what an easy job." Yeah, right. I wouldn't want it. Okay, okay. You got to know what you're doing. So there's a lot of configurations. Here you got a single drum or double drum. Typically, you use steel drums for the breakdown rolling. That's a phase that's referred to. The breakdown is the initial compaction right behind the paver. You'll see that these will be steel drums. Excuse me. And again, you can have the static or the dynamic. Whether he uses static or whether he uses dynamic is going to be based on that mix. Is it a sensitive mix? Is it a hot mix? Is it supporting me? So he can have three modes: static with the vibrators off, one drum vibrating, and one static, and both drums vibrating. He's going to use the best configuration to get that density. That breakdown rolling is the initial consolidation of that mat or compressibility. You've got to get that density. Again, if the screed isn't giving you that density, that's a problem right off the bat. Gotta have a certain density from the screed. The static form is from the weight of the roller and frame. It's just a dead weight. Okay, it's the weight of the machine, the weight of the drums, and so forth. Dynamic, they have a rotating eccentric weight in those drums. It's like a cog. But you can then adjust the frequency and the amplitude. Amplitude is the up and down vibration. Frequency is how many times does it go up and down, say, per minute. So again, the guy on that roller in the breakdown, he's got to know what he's doing. This should say single steel drum or double drum, but okay. Now you've got these pneumatic rollers. You've seen them, the wobblies. In construction, they don't call them pneumatic rollers, they call them wobblies. Because if you look at the wheels in the back, they wobble with broken axles. But they're obviously done, like that for a reason. They're kneading the asphalt. That's how you get your final density. Remember, the Marshall density test or the Marshall test is strictly impact. And that's why there's been so much controversy about the Marshall test. Is it applicable to what happens in the field? You're not simulating what happens in the field. Because for asphalt, to get that density, is you obviously want to knead it, just like when you're kneading dough with your hands. Now we have dough makers, but maybe your grandparents would make bread and they would knead the dough. This is what you're doing to the asphalt. You're manipulating it. You're getting that internal friction. You want to get those aggregates to lock into one another. So this is going to help slide the aggregates in. So you want to densify it. And these are also used on granular base materials. MI uses that as their final before they usually seal the base with a prime coat, waiting for the paving crews to start up. Pneumatic rollers. Okay? And this is what's used for the intermediate. You've got the breakdown, then you've got the intermediate phase. Call them intermediate. This is another phase of compaction. And they work behind the static breakdown roller. So you're going to get the static breakdown roller. He's going to leave little rims, ridges, I should say, imprints. This will take them out. Again, the pattern, and this will come out in the video, you'll see, it's key as to you want to make sure you have total coverage during the breakdown from one edge of the mat to the other edge of the mat, and same with the roller. Intermediate roller, the pneumatic roller, is also going to have total coverage. Factor force is the function of the wheel load of the machine. Tire pressure, tire design, and depth of penetration of the tires into the mix. Again, you can control the tire pressure. They can be adjusted based on the mix, the type of mix. Tire pressures range from 60 to 120 psi. I mean, should change that to kilopascals, but in the imperial. And just the weight itself. You'll notice that these guys can put ballast into the hopper of the roller, if you want to call it, right in there. Okay, this is like a bed. They'll put aggregate in it, lots of it, you'll see some of it, if they want to increase the dead load. Okay, so these machines will have a certain amount of dead weight from the manufacturer, just the framework and the tires and everything else. But you can also increase it by putting ballast. When we mean ballast, we just mean weight. Concrete rubble, A-base, whatever. Just put it in the back for extra weight. If it's a tender mix, okay, you got a tender mix here, you want to use low tire pressure. Makes sense. Stiff mix, obviously, you want a higher tire pressure. In the video, it'll say, should you change the tire pressure from wheel to wheel? Okay. If you got a stiff mix, okay, you need higher tire pressure. But you may have 7 or 8 tires around the back and the front of the paver. Should you adjust the tire pressure differently in those 7 or 8 tires across? Or should they all be separate? Anybody?
Shouldn't they all be the same?
You got it. They gotta be the same. Because remember, you're going across the full mat. So you wanna have that pressure evenly distributed across the full mat. So if your tire pressures are off, whether they're in the outside or the interior, or, you may have two at one pressure and then the third tire may be off and then whatever. Now, you're not giving even compaction. You're not gonna get even uniform compaction. Use an inspector, believe it or not. I don't know if the guys with MI or even with the city have ever gone out there and checked those pressures, contractors, or have the contractor check them while you're witnessing. Has anybody
By the,
worked on a paving crew?
I was going to say, by the way of Winnipeg roads look, probably not.
Probably not. Have they checked the screed? Is it flat? Is it uniform? Things to look forward to. And I know sometimes when we're starting out in this, we have a supervisor or a senior guy. No one's never told me to check. Okay, now you just do it. You say to your boss, we have to check that tire pressure. We have to check that screed. Yes, it's contractor's responsibility. But after you pave 5.6 kilometers of highway and then you find out that the pressure wasn't there and you're not getting density, it's a little late. True enough, from an end product point of view, that's the contractor's responsibility. But during your tailgate pre-construction meetings, every day you should have a quick meeting with the contractor. What's he proposing to do for the day? Okay, I wanna place 5 kilometers of highway. You ask them, did you check your machine? Did you clean the rollers? Did you clean the scrape off bars? Do you have ample supply of water to keep that drum moist? Is your screed functioning? Is your screed clean? Is your screen level? These are all things that have to come up at the pre-construction meeting daily. It should take 15, 20 minutes, as we call them, tailgate meetings. Okay? Check it. Because maybe your supervisor or your senior technician who's kind of above you, maybe he was never instructed. So it just gets on and on and on. That's what makes a good inspector. That's what makes a good inspector. Challenge in a professional way, though. Challenge your boss. Okay? You don't have to be indignant about it, but you be polite and you be professional. Discuss it. Okay? Anyhow, that just comes from years of experience. Okay. So keep in mind those drums got to be clean, because if your drums build up with hot mix, they got globs, you're going to see imprints in the mat. So those drums should also be clean of hardened asphalt. And they'll be moistened, you'll see on the video, and we'll go over it. They're spray bars. You want to use your drum, you want to keep it moist, not dripping wet, but it's got to be wet so it doesn't pick up the asphalt. And you'll see that sometimes when the asphalt is hot, the water is cold, you'll see a little bit of steam coming off. That's just the water. Hey, now you got steel wheel rollers. This is a little bit different. I haven't seen any of these around. A little harder. You may have a full drum in the back, but here you got individual ones here now. So you're going to remember it's going to be key. You're going to be basically crossing over the full width with that big drum in the front, because if you don't, with these, you're going to get a gap. But you can see the big drum in the back is going to cover in between. Steel wheel rollers. And we use them for the final rolling. Okay, so you got this single drum or dual steel drums for breakdown to get the initial compaction. You got the pneumatic for the intermediate rolling, intermediate phase, to tighten up, remove the ridge marks that may have been left from the breakdown roller, to give it that extra amount of compaction. And then you're gonna have the smooth drum final rolling, and that takes out again the ridge marks that could have been left by the pneumatic tires. Okay, especially if the mat is still a little on the hotter side, you may get more imprint of those wobblies. The steel drum and the final roller will take those out. You want to have a smooth, tight mat. Again, based on weight. They can either be three-wheeled or tandem. I very seldom have seen a three-wheeled here. Doesn't mean you got them, but typically they're tandem. I've also seen some where you have wobblies in the front, sorry, in the back, and a steel in the front. So you've got dual. Different configurations. But essentially, you've got the breakdown rolling, the intermediate rolling, and the final rolling. And at the final rolling, you should have your density. You should have a smooth, tight mat. Again, the tight mat is going to be based on how well the mix is designed, how well it's placed. Don't have segregation. Okay. Now, how many of you guys have been involved in the coring of the pavements? Why are we coring? We put a nice mat down. Now we're going to screw it up by having holes all over the mat. What's the purpose of the cores? Anybody?
Calibration of the nuclear density gauges.
Yep. And what else?
Testing the actual density of the asphalt.
Yes. It's probably that's how you're going to calibrate the gauges. You're going to determine the actual density of the cores, weight in air, weight in water, just like a briquette. And you're going to take a series of readings with a gauge beside those cores, and then you're going to correlate the density reading by gauge versus true density. The true density is cores, weight in air, weight in water. You can't go wrong with that. Nuclear gauge can be affected. You got a thin lift, especially if this is the bottom mat. Okay, typically you're going to calibrate your gauges on the bottom mat because you're going to cover it over with a top layer. So you're going to calibrate. But the mat on the bottom might only be 40, 60 millimeters thick. And even in the base, even in the backscatter, when you're taking densities with that backscatter gauge, in the backscatter mode, it's shooting through the mat, it's picking up the granular base density, coming back up, and the density you get in the gauge is now the density of the asphalt plus the granular base. If the densities are the same, I'm just exaggerating a little bit, or very, very close. If your asphalt densities are 2300 and your mat is 2300, then the gauge doesn't know whether it's all granular base, all asphalt, half and half. All it knows is it's got the same density. If the reverse went, and let's say, for example, you put an asphalt mat over, we would never do it, but I want to just sort of give you the configuration, over straight silty clay subgrade with densities of only 1600 versus a mat density of 2300. You put your gauge on it, you're in the backscatter mode because you didn't prime the little hole to go direct transmission. Your gauge is now shooting through 2300 kg material into 1600 kg material, comes back up, the detectors pick up a density of whatever. Now this density of 1800 is influenced by the 1600. You got to correct that. Thickness nomographs was the old way, now the gauges can do it internally. But now, that's why I don't like backscatter. Like direct transmission, where you actually prime a hole in the thickness that you're going to shoot, and it always shoots up. It doesn't shoot down. Backscatter, your radioisotopes shoot down. They're bombarded. They're charged differently. They come back up. The detectors pick them up. So now they're influenced by two different types of densities. Okay, so cores are the true indication. Weight in air, weight in water. Okay, so we've calibrated the gauge. We've also taken true densities. What other reason? Why would we sometimes core? Let's go to, instead of a prescription spec, let's go to an end product spec. This is an end product spec. In other words, QA, right? Ray? What would QA include? Quality assurance. What are you assuring in this case?
The proper thickness, the proper density of the.
You got our thickness. Remember, the design, your elevations, your road design tells you you got to have 80 millimeters of asphalt.
John, would that be correct to take a borehole in the joint?
No, you can see he's not in a joint. There's the two pavements. There's the two mats here, but just back of his boot here. See where my cursor is?
Yeah.
No, he's taking it out. What he may do here sometimes is if you, the second one that he's taking out, he may want to check to see this thickness versus this thickness because maybe of crossfall, but it should be the same. You may also look at the fact of what is his joint like? Is he gonna have good bond between it? I don't know if you noticed it here, but when they're, and those of you that work for MI, I usually see them put a tack coat on the bottom, but they don't tack the edges. In Ontario, they always tacked the other edge of this mat. So in other words, if this mat went down first, and then you're gonna be placing this mat beside it, you would tack not only the bottom, but you'd also tack the edge. And here, I don't know if MI does that. Any of you guys that have worked with MI recently, do they do it? So now he may be just checking the tack on that joint. Good question there. So I have to say, never seen it. Okay, Ray, you work with MI, yeah, or even in the city, you haven't seen them tacking that side, no?
Yeah, I never seen one when I was in MI.
You never saw it in MI. And again, because this mat, if you're doing it side by side, so in other words, they're gonna pave this from 8 AM to 12 noon, and then they're gonna switch over and go 12 noon, whatever, that mat may still be warm. And maybe the tack isn't that important in that respect. But if it's the next day, so Clive, you're saying the next day they will. So you've been on a job where they have done it the next day. Yeah, and that was with MI, Clive, or the city? MI. Well, that's good because I remember one time they didn't do it. But
From what I've seen, I don't think MI really pushes it, but if the contractors want to do it, then they can. Like when I
well,
was
yeah,
working on PTH1, one contractor wasn't doing it, and then they got booted off the job for multiple reasons. Then the next contractors came and they did it. So I don't know if it was a contractual obligation, but it was just maybe that's just what they wanted to do.
Well,
Yeah, I think so too.
Yeah.
Based on the contractor, I work with Coco Paving and Maple Leaf. They did it.
so this again is something that, different agencies have different stipulations, but that's key. I mean, you don't want a longitudinal joint in Portland cement concrete to open up. Would you want one on asphaltic concrete? No. So why not bond it? Why not put a tack? It's not gonna hurt it. I mean, if you flood it too much, okay, but it's like anything else. So maybe just good caution, just to be on the safe side. Tack it. You always tack the bottom. See, when you do the granular base, it's a prime coat. You're sealing it, and it will give you you'll protect the granular base. When you lay your first mat down, and then you seal it, that's a tack coat. Now you're bonding the bottom mat of asphalt to the upper mat of asphalt. Okay. So Maple Leaf did on PTH 15, 2019. Good. So maybe, see, even within a company, maybe it's the superintendents. Some believe in it, maybe some don't. Okay, so cores. We take it out for determining density and thickness. Those are two main reasons. Taken for density and or thickness determinations. On an end product specification, he may have penalties if he doesn't put down a minimum of 80 millimeters or whatever the spec states. Okay. Typically, you'll take it from the sample that you're placing it. Bulk specific gravity of the core is determined, and using that with the maximum specific gravity or Marshall density, the percent compaction is calculated. Many agencies don't use Marshall densities. They'll say that this mix, the maximum theoretical density for this mix is such. So their specifications is a certain percent of GMM or maximum density, not maximum specific gravity, maximum density. City of Winnipeg, I believe, and MI talk about percent of Marshall density. So in other words, you're sampling asphalt periodically from the project site. You take it to the lab, you compact it. You're going to try and determine maximum density on those cores. Typically, you'll have them before the next day because sometimes they don't do those densities, whether it's with a nuclear gauge or cores, till the next day. So now they'll say, okay, for the 5 samples that were obtained, the densities, Marshall densities are this. So the test taken on that area that the first sample was obtained from, you would use that Marshall density. Then the next Marshall density. So it's a percent of that Marshall density. Or you might say for yesterday's paving, our average Marshall density of 5 tests is this, and then just do density right across. Typically, I would like to use the Marshall density for the area that those sample was obtained because it can change. So you might be fighting a 97 or 97.5% just by using a slightly different Marshall density. It's against the same thing. Is your proctor applicable to the area where your densities on your A base were taken? Same thing. They got to go hand in hand. So, okay, cores, weight in air, weight in water, and you can calculate bulk specific gravity, then you can calculate your density based on temperature of the water. Okay, any questions? It's pretty straightforward, but there's so much that comes in, and that video, like I'm saying, typically, again, when we've had face-to-face, we would go through those videos in class. I know through WebEx it doesn't always show up really well, but I am insisting, please watch those 3 videos. I've got questions pertaining to it because it is reinforcing the placement here. Covers a lot of things. It covers the point actually of how you make a construction joint. Remember, we have construction joints in concrete. You finish paving for the day, you put a bulkhead in, the next day you're going to continue from that joint. Same thing with asphalt. You're paving 30 kilometers of highway. First day you're gonna place and compact 5 kilometers. You got to put a joint in it. The next day you got to make sure that those joints butt up at the proper elevation, proper crossfall, and good bond. So how do you leave that joint at the end of the day is going to be very important as to how you take off. And that video goes through something like that. Now, I don't have any questions on the joint. I'll be honest with you now. I don't have any questions on the joint construction. I've got a few other questions there, but there's not many questions, but I've got 3 or 4 questions pertaining to video. I think it's a good resource also for future work if you guys are going to be graduating and you're going to be working on paving jobs. It's good to watch. Any questions so far?
I have a question about the lab, not the material. So I
That's
don't know.
fine. Go ahead. Yeah,
That's-
go ahead because we have no lab today, obviously, because we're finished. This lab will be due next week, but go ahead by all means.
Okay. So I'm comparing. So I did the process with taking the 4% air voids and finding an ideal asphalt content. So
Right.
I'm comparing it against the City of Winnipeg Type 1A spec, and I'm seeing I need to check against the 14% minimum for VMA,
Right.
the 7 kilonewtons minimum for stability, and then the 16 to 6 for the flow index. So that's only 3 graphs. What about the other ones? Like that's it.
You got stability to plot. Sorry, you got the density to plot, and you got voids filled with asphalt to plot. That's the 6.
Yeah, I've plotted all 6 graphs. I'm just asking, like, I'm not seeing other check values here. Like, this is it. This is all of the values on this page 11 of the City of Winnipeg.
Right, because now you got to look into consideration. voids filled with asphalt is dependent on what? It's a function of what?
VMA.
When you're calculating it, what's it a function of?
Well, it's a function of voids and mineral aggregate, right?
Right, and what else?
I'd have to check the formulas again. Let me see.
Just the effective AC content, the effective one, the one that isn't absorbed. It's gonna
Right.
be a function of your VMA. So that's why there's really no spec on it, because voids filled with asphalt is a function of VMA, not of total mix.
Hmm.
VMA is percent voids and mineral aggregate based on total mix. Voids filled with asphalt is a percent of the VMA.
Okay.
So whatever your VMA, so that's why there's really no, in asphalt technology, there is sort of a minimum voids filled with asphalt that you should have, but there's no spec on it because it's a function of VMA. If your
It's just not.
VMA, if your VMA is in spec and it is what it is, your voids filled with asphalt is going to be dependent on that plus your effective AC content.
Hmm.
But it's still good to
Okay.
plot because it gives you an idea of what's happening.
So when we write a report, do you want us to just say, okay, we got here's where the asphalt content value fell in these three graphs, and that's
Well,
what you're looking for?
Yeah, you're going to tell me your optimum AC content based on 4% air voids.
Yep.
Okay, so again, or 3.9, maybe like I say, sometimes you have to just go up a little bit or down a little bit to make sure everything else comes into play, stability and flow and VMA. Then you will state in your job mix formula, the optimum AC content is 5.25, whatever. And at 5.25, the criteria for City of Winnipeg specifications for VMA, air void, blah, 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 have met, and you will give those values.
So talk about how it meets the city spec
Just
in
say,
that
yeah,
for
just tell
each
me it meets.
thing.
Yeah, you can just state that at 5.25% AC, the optimum AC content, air voids, stability, flow have met the City of Winnipeg specifications. And then just summarize them what they were, okay, at 5.2. I can always go back and I'll notice that on the graph. But you're covering letters sometimes. Keep in mind, our client sometimes doesn't look at graphs, doesn't look at tables. He may not understand it. But if you tell them also in words or summarize it, a lot of them just read the letter. That's all they want to know. They read the letter. Oh, it's good. Away they go. They don't read the rest.
You're just
So when
wanting
you're summarizing a report, try and summarize in the context or in the body of the letter report what your results are. Yes, they're attached. I, for one, would know it, but would your mother know how to read those? Oh, I'm being a little bit facetious here, but I'm just trying to state again. You know, if you told her and she could read and told her in the letter report, she would read that and say, oh, yeah, they're good. I think that the reader is not that knowledgeable.
I think I'm wanting to put too many details in there to just try to cover my butt, which I don't need to do.
No, more is not necessarily better. Remember, when you're writing a letter report, you want, give me the meat and potatoes. Forget the gravy. Forget the dessert. That's fluff. Architects love fluff. Okay, engineers, we don't like fluff. We like brass tacks. Get to the point. What does KISS stand for? You ever heard that acronym?
Keep it simple, stupid.
Can't use that. It's keep it simple, student. Okay, can't use the word.
I think
student.
Fabian's got it.
What's that?
I think Fabian got it. Keep it short and simple.
Yeah, keep it. Actually, the acronym stands for keep it simple, stupid. But we can, you know, you don't want to use that term. So it's keep it simple. So I just say keep it simple, student. Okay, KIS. Keep it simple, student.
I don't know. That's what Otto taught us.
Well, yeah, Otto's a little different compared to most. He's retired now. Are you talking about Gebhardt?
Yeah, he taught us drafting in first year.
Yeah, I think he's retired. I don't think he's back this year, if I'm not mistaken. Mind you, he's been there, I think, since Adam and Eve were born. Anyhow, yeah, so again, just in your letter reports, I don't know what the technical communication course was like for you guys in first year, and I've always made my comments that it should never be in first year, it should be in second year. Because in first year, many students have not worked in the industry. After the first co-op, they may have been exposed to keeping records. They may have been exposed to writing daily reports. So in second year, it's going to make it a little bit more knowledgeable for them, a little bit more applicable, having done it in the field. But in first year, if we've never been involved in this industry, and I don't know what just talking to students like yourselves, I get the impression that it's spent more on how to writing a resume and how to write a covering letter, but not so much as far as technical reports. I could be wrong. Do you guys actually take technical letter report writing in first year technical communications?
It's been a while. I can't really remember. We might have.
You can't remember. It's only been 2 years ago. Yeah, Clive says yes. Okay. And did you find it helpful? Can you go back now when you're writing these letter reports? Is it helpful to write these letters? The setup, you know, many times some say, well, what's the difference whether I have the letter set up properly or not? Well, from a professional point of view, it should be. I'm paying you $300, $400, $500 a test. I want my money's worth. You still have the text, so you refer to it, need be, right. And the more you get involved with it, day in and day out and day in and day out, you eventually, it comes in and sticks in your head. And there's a lot of ways of writing a letter report, but typically you want to tell the client right up front. I've also been taught where many times I write a letter report, I give them the results right in the first paragraph. So they don't have to read to the end and get the summary. In my first opening paragraph, I may open my sentence up as to what I did, but right after that, I give them the results. And then I write after that why I gave them results, who retained me, who asked me to do the testing, what standards did I follow when I did this test, what standards did I follow when I did this test, were there any deviations, and so forth. But the first paragraph right up front, I gave them the stability, the flow, boom, 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 whatever. I gave them the density, whatever the case may be. I gave them the gradation results, whatever. Okay, stated. Gradation method, project specifications, finished. Then I give him the rest. Tell him he can go to the attachment if he wants, whatever. So there's different styles, but the main thing is you want to be concise. Concise does not mean overly detailed. Concise means to the point. Brief, but to the point. Okay. Yeah, sometimes, like I say, it's not easy to write. It takes long time. How many people rely on spell check?
I think
Or do you
everyone.
just check your own spelling?
Well, everything you do, your text corrects it for you, your Microsoft Word corrects it.
Right, but what happens if you use the wrong word in the context of the report and you didn't notice it? Bad for the brain, though, yeah. If you're using spell check too much. I'll be quickly and brief here. Years ago, I was at a report writing conference seminar. I took a small one-day course. And our instructor said that this one lady was applying for a job with the civil department. She was she worked in government, she worked for the Fed, she worked in the provincial, but now she was going to a small town, the civic department government. And she, in her letter, she wanted to say that she had numerous years of experience in public office. Okay, so as the interviewer is reading the letter, it states that she had 20, 25 years of experience in public office. Spell check didn't pick it up. It was spelled properly. Right? So you heard what I said there. Could have been a little bit embarrassing. But, so if you read something, give it to your other partner in your lab to read it, and then give it to the third person. Because you could be reading it 2-3 times and not notice your own mistakes. Can't see the forest because of the trees. Ever hear that saying or something close to it? Can't see the forest through the trees? You won't pick up your mistake many times. Your brain doesn't pick it up. So let somebody else, or go for coffee, come back and read that letter an hour and a half later, you may pick up those errors. Yeah, check the works fine too, yeah? So if you're into it and you're frustrated, whatever the case may be, leave it alone. Go grab a coffee, go watch some TV or something, come back, and you'll find your errors usually, okay? Anyhow, just basic what happens. Your mind just zeroes in on other stuff, doesn't pick up the mistakes. So I try not to use spell check. And yes, sometimes it'll correct it for me. But always do it manually. Let somebody else read it to see. Okay, any other questions here on the lab?
John, can I ask you one more question?
Oh, by all means, go ahead.
Yeah, I just want to know, like, are we going to use the GMB and GMM and the flow 0.25 millimeter based on the number you give us on the lab night? Or do we change it based on our lab 8?
No. Forget lab 8 now, because
Okay.
parts of lab 8 would not work well with lab 9. So I basically gave you a new lab 9.
Oh,
Typically, you don't, obviously, when you're doing a Marshall mix design, you're gonna use the
Mhm.
specific gravities that you obtained.
yeah.
Yeah, so just look at it as this is your new data, okay?
Okay.
I gave you the flow, I gave you the stability, and I believe I gave you the mass of AC and the mass of aggregates. And
And we still have to calculate the P bulk again, the new one, right? We're not using
yeah.
anything from lab 8, right?
yeah, if you look at
Okay.
that spreadsheet I gave you, there is no percent AC. I gave you the design, what you're shooting for,
Yeah.
okay?
Yeah.
You know how to calculate the true AC, eh?
Yeah. Yeah.
Remember, we're also designing everything on percent of AC percent of mass of total mix. Remember, there's 2 ways of doing it. You can calculate AC based on mass of aggregate. You can calculate AC mass of total mix. Our mix design, City of Winnipeg, Asphalt Institute, typically go with mass, AC mass of total mix.
Mhm.
So it's basically AC divided by AC plus aggregate, right?
Yeah, that's right. Yeah.
Whereas the other one would be AC divided by mass of aggregate. And that's what highways does. And it's both acceptable. It's just that you got to know what your mix design is based on.
Okay. Thank you.
Anything else? Anyhow, next week, where you'll be writing your exam, your final quiz, whatever. And then by 10 o'clock, you'll have your lab submitted. You can submit it ahead of time if you want, whatever. Hopefully, I'll be speaking to many of you. If I'm not, good luck out there, guys. I'm sure you're all going to graduate. I'm sure you're all going to be finding employment if you haven't already. And I travel from time to time. I head out there and I see the industries and I see you guys out there. So the best of luck. It's been enjoyable. I just feel bad that we couldn't meet in person and go face to face. Even have a cup of coffee together sometimes, or a box of donuts I sometimes bring in. Anyhow, all the best. Keep safe. And we'll see you guys around, I'm sure, somewhere in the industry or from time to time, just on LinkedIn or whatever media you guys choose to follow. Any questions again, please don't hesitate. Send me an email. I'll take it from there. All the best, guys. Okay. Everybody have a good day. Good week. You're welcome, Jim. Fabian?
Yeah, thanks for everything, Joan.
Oh, you're welcome. All the best, Kelly. We'll talk
Yeah,
to
you too.
Yeah.
Are you still gonna adjust that lab?
You want that half mark adjusted?
Sure. I ain't gonna turn it down.
I'll adjust it, but like I say, it's not gonna make anything on your final, but I'll do it.
Okay.
Just to keep you happy, Kelly.
Okay, thanks. Have a good one.
Okay, take care.